Hey everyone, welcome back to another DarkSec video. I am Dark, and today we're going to be talking about a new at the time of recording this vulnerability called Zero Logon. Learn about and exploit the Zero Logon vulnerability that allows an attacker to go from zero to domain admin without any valid credentials. This is a bit of a spooky one. Speaking of spooky, this is a TryHackMe room that was developed by SpookySec, and this video it is actually coming out in tandem with the room. So let's go ahead. We'll dive right in with task 1, the 0-day angle. Zero Logon, the 0-day angle. About the vulnerability. On September 14th, 2020, Secura released a white paper for CVE 2020-1472 that allowed an attacker to go from 0 to domain admin in approximately 1 minute. They dubbed this vulnerability Zero Logon. Zero Logon is a purely statistics-based attack that abuses a feature within MSNRPC, so Microsoft NetLogon Remote Protocol, and MSNRPC is a critical authentication component of Active Directory that handles authentication for user and machine accounts. So this means your typical domain users and then the actual computers that are part of the domain. In short, the attack mainly focuses on a poor implementation of cryptography. To be more specific, Microsoft chose to use AES CFB8 for a function called Compute NetLogon Credential, which is normally fine, except they had hard-coded the initialization vector, something you never ever want to do, to use all zeros instead of a random string, hence why we get Zero Logon here. When an attacker sends a message only containing zeros with the initialization value of 0, there is a 1 in 256 chance that the ciphertext will be 0. That is very good odds, especially when we can script this out and have it happen in under a minute, ideally. But how is that useful to us? We'll touch on that note in the following sections. And one quick note before we go on. For this room, you may have noticed I already have the TryHackMe browser-based machine up here. This, I think, is a subscriber-only room on TryHackMe, and as such, I'm actually using the subscriber attack box for this. I recommend you do so as well. That is because setting up for this exploit is incredibly inconsistent. I actually just got done before recording this video troubleshooting this for probably about an hour to get everything to be consistent and to work to the point that we were happy with it to go live. So please use the TryHackMe attack box. If this room eventually goes free, I believe free members also have an hour of deployment time per day for the attack box, so please use it. It is more consistent. It's going to make your experience with this room a lot easier. One other note, this room is ranked as hard. It's not very difficult. It is difficult if you want it to be. The part that makes it difficult is we are actually going to be modifying a POC, a proof of concept. I'm not going to actually be doing that. The author of the room, SpookySec, actually provides a pre-made POC that we can just download. I'm going to be walking through how we would actually modify the tester script that is provided by Secura. However, we don't actually need to do that in this case since it's ready made for us. I do recommend, if you're interested in doing exploit development, I do recommend walking through the proof of concept modification so you understand what is actually going on there and doing it for yourself. However, if you just want to see how to run this really cool new exploit and you want to get an idea of how and why it works, then go ahead and just continue on and do what I'm going to do. So about machine accounts. Normally, if we tried a statistics-based attack on any user account, we'd get locked out. This is not the case if we apply this principle to machine accounts. Machine accounts behave in a much different way than standard user accounts. They have no predefined account lockout attempts because a 64+ character alphanumeric password is normally used to secure them, making them very difficult to break into. They're not meant to be accessed by an end user by any means. In certain circumstances, we can dump the machine account password using a tool like Mimikatz, but if we're at that point, we've already compromised the machine, and we're looking for persistence within the domain, not lateral movement. Abusing the vulnerability. Machine accounts often hold system-level privileges, which we can use for a variety of things. If you're not familiar with Active Directory, we can take the domain controller's machine account and attempt to use the granted authentication in conjunction with secretstump.py, which we'll be doing here in a little bit. Secretstump is a password dumping utility. It's like Mimikatz, except it lives on the network instead of the host, to dump all of the passwords within the domain. At this point, we have a rough kill chain starting to form. So we use zero logon to bypass authentication on the domain controller's machine account. So this is going to go through and it'll actually reset the password. In this case, for the machine account, we are going to be resetting that to a blank password, which makes it really easy. We'll run secretsdump.py out of Impacket to dump the credentials, and then we're going to go ahead and attempt to either crack the credentials that we have from that, or we're going to pass them just to log directly in. And then we profit by just owning everything. Hacking the planet, if you would. Analyzing the MSNRPC logon process. At this point, we know a vulnerability exists, but we're not quite sure how to exploit it yet. We'll be covering that soon, but what we do know is that there's a vulnerability within the way Microsoft handles authentication within compute net logon credential or function of MSNRPC. To better understand this vulnerability, we need to do a bit of a deeper dive on how Microsoft handles authentication to NRPC. To analyze where the vulnerability occurs, we'll be using the diagram provided by Secura as well as the Microsoft documentation to decipher the magic behind zero logon. And you'll actually need the Microsoft documentation for a couple questions later on in this room. The sources can be found at the bottom of this task, and I do recommend digging into these a little bit more, especially if you want to understand, again, the nitty-gritty of why this works. So we have a simplified net logon authentication handshake here on the left, and here we can see the zero logon attack, which effectively boils down to filling particular parameters or message parameters with zeros and retrying the handshake a few times in order to set an empty computer password on the DC. So here you can see that we have a client challenge, the server challenge, so it comes back, you're attempting to connect, the server is going to challenge it, and you have your session key, which is going to be the key, or KDF, which is going to be the secret and the challenges. Essentially, this is a back and forth process to negotiate using a variety of secrets in order to actually authenticate to the domain. I won't go too far into this just because it does get a little bit into the weeds, but we're going to use that again with that initialization vector not being random, and instead it's just all zeros. Thank you, Microsoft, for that one. To be able to authenticate and reset the password to 0, which we can see what we're doing here at the end. So step 1, the client creates a netar server rec challenge and sends it off. This contains the following values. So we have the domain controller, the target device, which is also the domain controller in our case, and we'll be exploiting a domain controller in this room, and then a nonce. In our case, it is a 16 bytes of 0, and that's just because we're taking advantage of that random chance. The server receives, so for step 2, the server receives the netar server rec challenge. The server will then generate its own nonce, and this is called the server challenge, which we saw up here. The server will send back the server challenge back. Step 3, the client, us, will compute its net logon credentials with the server challenge provided, which we can see right here when we're going to send that back. It uses the netar server authenticate 3 method, which requires the following parameters. And you don't need to know exactly what's going on here. This is just, we're going into the nitty gritty so that if you're interested in doing more development work, you can see what it looks like. So it requires the following parameters. We have a custom binding handle, and Impacket's just going to do that for us. An account name, the domain controller's machine account name, which in this case, it's just going to be DC01. A secure channel type, and again, Impacket just takes care of that for us. We do need to specify a little bit there, which is what it's doing right here. The computer name, which is going to be DC01 again. The client credential string, and this is going to be 8 hextents of the 0, the null bytes, which becomes at 16 bytes of 0. And then we have the negotiation flags. And the following value will be observed from a Win10 client with signed seal flags disabled. And this is just provided. And then step 4, the server will receive the netar server authenticate request and will compute the same request itself using its known good values. If the results are good, the server will send the required info back to the client, which is what we see right here with the server sending that back. At this point, the attempt to exploit the zero logon vulnerability is underway. The above steps will be looped through a certain number of times to attempt to exploit the zero logon vulnerability. And we'll see this in the actual exploit itself. It's pretty quick in this case since we're going to be using a machine that's already on the AWS infrastructure. and the TryHackMe network specifically makes it pretty quick. If you want to do this elsewhere, your mileage might vary, but we'll see how that looping process occurs. The actual exploit occurs at steps 3 and 4, and this is where we're hoping for the server to have the same computations as the client. And this is where that 1 in 256 chance comes in, where that's not a very small chance. This, relatively speaking, when it comes to cryptography, this is actually really big, and we have really good odds of hitting this. So step 5. If the server calculates the same value, the client will re-verify, and once mutual agreement is confirmed, they will agree on a session key. The session key will be used to encrypt communications between the client and the server, which means authentication is successful, which is what we can see here as that final authentication being successful. And again, this is what that normal logon process looks like, and this is what that exploitive process ends up looking like in our case. All right. From there on, normal RPC communications can occur. And again, we have some sources down here below. I do recommend digging through these. They are very interesting, along with the white paper for this, and I believe that's mentioned in the next step. They're absolutely worth your time to go through. Let's go ahead and move on to task 2, which is going to be Impacket installation. Now, this is very important. Please follow this per the guidance here. Otherwise, this will not work. And again, we're stating here that you should probably use the attack box. You can get this to work on your own Kali installation. It's very, very finicky though, and it's something that, again, we recommend using the attack box just for consistency. So with this, you can go ahead and take these commands and copy them into the actual terminal, run them one at a time. So this is going to go through and install a virtual environment to run all of, to actually install Impacket into. This ensures that you are going to have an isolated and consistent Impacket installation, which is going to be the same version that we were using in this room. So you can go ahead and run through this. Again, I've already done this in this side where I've got the commands copied into a text document here, and I've got to run them in this case, and I've actually got that virtual environment active, which this step here is going to do. You don't need to know necessarily what's going on in here. This is something that if you've played with installing Python tools before, you probably played with virtual environments, as it makes this a lot more pleasant, and you end up not having as many issues. I will let you go ahead and fuss around with that. Again, follow these instructions, and it should be pretty easy. Just please follow them carefully. And then credit to Onushin, there we go, in the TryHackMe Discord for suggesting Python virtual environments. You saved Spooky a headache from what I understand. And then go ahead and install Impacket in a virtual environment. We'll go ahead and mark that as completed. And then I'm going to move on to task 3, which is going to be the proof of concept. Modifying and weaponizing the POC. This is where the fun stuff comes in. POC and you. Proof of concepts, not poof of concepts, are incredibly important to every exploit. Without them, the exploits are entirely theoretical. Fortunately, Sekiro was able to provide a working proof of concept for Zero Logon, which you can find here, that was 90% of the way there, and this actually ends up being, if I remember correctly, this is just a testing script here, which you can take, and because it accurately does diagnose that it is vulnerable, you can take this and expand upon it, which we've done in this room, to have a working POC. We simply needed to make an additional call to change the password to a null value, and we can see recall figure 3 from task 2, where we actually saw this process as it normally would happen. And Sekiro was even kind enough to give us the method we need to call, which is going to be this net server password set 2. Do open that. I have it open here. We're going to take a look at that here in a minute, and that's all we need. Looking up the method from the Microsoft documentation, it's very similar to the hnet server authenticate 3, so we're going to reuse some of the same variables from that as well as the structure. So analyzing the proof of concept. Before we continue any further, you should download the POC from Sekiro, which can be found here, and you can grab it just here. It's just a raw content. Copy it in and go ahead and add it in there. If you would like to follow along for editing the POC, you can go and grab that, and we'll break down that a little bit right now. The script may seem quite daunting at first, but it's quite simple. If you think back to figure 1 from task 2, and again, this is how it normally happened, you'll see how it all starts to fit together. Let's start by breaking the POC down. We're going to do this in the order of execution / importance, so it's easier to digest. So here we have our first bit, which is going to be declaring variables, and importing various libraries that we are actually going to need from Impacket. And you can see that pretty much all these are just Impacket libraries. Lines 1 through 4 import the required modules from Impacket, specifically the NRPC, EPM, crypto, and transport libraries. Additionally, on lines 6 through 8, a handful of other miscellaneous libraries are also imported. However, the impacted libraries are the star of the show here. Lastly, on 9.5, we're defining a constant, similar to a variable but never changes, that sets the maximum number of retries for zero logon to 2,000. If you're particularly unlucky, it can take all those. So lines 78 through 86. So next we skip down to the very bottom of the script so that some of the other variables will make sense later. Line 1 is essentially declaring a main function within Python. Line 2, we are checking for the amount of parameters and ensuring that it's exactly 3. So we need the zero logon script. This is how we're running it. Then we need the DC name, which we can get from scanning it, and we'll take a look at that in a moment. And then the IP of the box that we're attacking. Lines 3 through 5 are printing the help menu only if it's greater than 3 arguments or less than 2 and exiting. So this is just printing what we need to do with the actual script. Pretty standard for Python tools like this. If the required arguments are supplied, on line 8, the arguments are passed into 2 variables, DC name and DC IP. After the arguments are passed, DC underscore name is stripped out of the $ character, or stripped of the $ character, as the DC name variable shouldn't have it. The user account name should, however. Afterwards, it's passing the 2 variables and an additional modified variable into a module called perform attack. So jumping back up a little bit, let's go to lines 57 through 73. So line 1 is defining where the variables are passed into for the local function, and then you can see the DC name is being passed into the DC handle variable, DC IP is being passed into the DC IP variable, and then DC underscore name is being passed into the target computer variable, all of which will be used later or passed into different modules. And if this is sounding a little bit confusing, this is specifically going through and defining all of the items that we would need to supply that method that we were looking at beforehand, the one up here, in order to successfully authenticate, to actually abuse this vulnerability. So line 4 sets the variable RPC underscore con equal to none. This will keep track of consistency, or consistently, to check and see if the authentication is successful, and if it's not, the script will continue until 2,000 retries is hit. Line 5 is where the actual retries for zero logon occurs in the form of a for loop. Line 6 sets the RPC underscore con variable to the output of a different function called try0authenticate, with a couple of variables being passed to it, specifically DC underscore handle, DC underscore IP, and then target underscore computer, all of which we addressed earlier. The next lines are simply checking if RPC underscore con is equal to an invalid login attempt. If it is, print equals. If not, print success. If 2,000 retries is hit, print attack failed. So if we run through all these and we still don't get it, that means it failed. Going up a little bit further, let's take a look at lines 20 through 25. So line 1 is defining the try_0 authenticate function and is taking the previously mentioned 3 variables as input and passing them into the function. Lines 3 through 6 are establishing a bind in session with NRPC over TCP IP so that we can communicate with the domain controller. This just means that we're establishing a session so that we can actually start talking to it and start attempting to authenticate and getting lucky with this. Going a little further down, let's take a look at lines 27 through 40. So lines 1 and 2 are establishing 2 new variables, plaintext and ciphertext containing 16 bytes of 0, so no bytes, which will be used to exploit the zero logon vulnerability. Line 4 contains a variable called flags. These are the default flags observed from a Windows 10 client using AES CFB8 with the sign and seal bit disabled, and then credit to this is from Secura. And again, I do recommend checking that out if you want a little bit more information about this exploit. Line 6 is where the real fun begins. This is where step 1 begins in figure 1. The client creates a net R server rec challenge containing the following information required by the Microsoft documentation. And again, this is what we're going to see here. which are the 7 items. The primary name of the DC handle, the computer name being the target computer, and the client challenge being 16 bytes of 0, so 16 null bytes again. And the client will receive back, which will be used in figure 1, step 2. So we're starting that communication, we're sending the initial attempt, and then we're going to receive back the server challenge. And here we can see that we're accepting that server challenge right there. Line 8 sets up a try accept. We'll see the rest of that in the next few lines, but in line 9 is where we actually attempt to exploit the 0 logon vulnerability, and this would be figure 1, step 3. And again, this is the the normal attempt to log in. This section requires a fair bit more information per the Microsoft documentation for NetR Server Authenticate 3, and the following is required. So we can see that we are looking for the primary name, the account name, the secure channel type, computer name, client credential, and negotiate flags for this specific method. On line 9, we supply the DC underscore handle as the primary name, the target computer, plus a $sign as the machine account name. So recall, machine accounts do not have lockout policies because they're thought to be a little bit more secure than that since, well, they have very long alphanumeric passwords. The secure channel type as the secure channel type previously established over RPC, the target underscore computer variable as the computer name, the cipher text, which is again our null bytes, attempting to abuse 0 logon, and remember that there's a 1 in 256 chance that the cipher text will be the same as the plain text. And lastly, our flag variable that mimics those of the Windows 10 client. Additionally, we expect to receive 2, possibly 3 things back from the server upon hopefully successful exploitation of the 0 logon. The server credential and the account RID, or the account RID specifically, only one of which we're actually going to use. So going down a little bit further, let's take a look at lines 44 through 54. So line 4 is retrieving the error code from the server underscore auth variable, or the variable assigned to establish an authentication session with the target device. If successful, we're going to return the RPC underscore con variable, which will inform us that we have successfully bypassed authentication with 0 logon. Lines 3 through 12 are simply error handling lines so the program doesn't break and exit after receiving an error back. So end of transmission, what's next? And that's all there is to proof of concept. It's not some scary giant scary monster. It's even successfully exploit the 0 logon vulnerability for us, but it stops and doesn't do anything further. So how do we proceed? And again, hopefully this breaking it down, while this might be a little bit overwhelming at first, if you go back through and read through it again, you can see how this is meant to be mimicking that actual process. So all we're doing is taking the actual process which should happen, and we're taking advantage of the part of it that is flawed, and we're adding a little bit of error handling around that so that we can effectively take what is wrong about this and transform it into a working proof of concept in this case. So good question. Next, we need to take a look at the Microsoft documentation itself and see what we can do to interact with NRPC itself. If you're not familiar with NRPC and you're not that technical of an individual, look back at the last step in task 2 figure 3, and it tells us what we need to do in this specific case. So if you take a look back at that, you'll see again in the task 2 figure 3, that is the actual when we're abusing all of this. So what's it all mean, Doc? After going back and peeking at figure 3 on task 2, or researching how to reset a password on over RDP, you should have come across the following document. So here we can see that we have a little bit of Microsoft documentation, which again is what we had before, which is the actual method we are going to call that. Since we've already successfully exploited 0 logon to authenticate, we can go through and just reset the password to be blank, which means that we can now authenticate to the domain controller using secretsdump.py to just dump all the secrets with a blank password. So the document outlines what information is required to change a password over NRPC, and the following information is required to do so. And again, this looks very similar to what we saw before for the previous method we were looking at. So going back and looking at NetR Server Authenticate 3 and NetR Server Password Set 2, we already have a handful of the information required, like the primary account name, secure channel type, and the computer name. So we simply need 2 values, the authenticator and the clear new password value. Both of these are documented for Microsoft, so let's take a look at the authenticator first, which we have right over here. And we'll pull that up just for a moment to take a look at what that is. We can see, again, this is pretty short, and we have the bits that matter here. And suddenly we've hit another unknown, so we need this net logon underscore credential. Fortunately, Microsoft does have documentation for the net logon underscore credential as well, which we can see here. And as you can see, you can go pretty far down the rabbit hole for this, and I do recommend reading a little bit further into this, but this is how we went through and took all those, and we're able to bring it back into the POC. Per the documentation, netlogon underscore credential can take 8 bytes of data. The second bullet point outlines that the data field carries 8 bytes of data, or 8 bytes of encrypted data as specified in the netlogon credential computation. Fortunately, we know this value thanks to 0logon, and it's 8 bytes of 0. In terms of the timestamp, it's a D-word value, so that can be either a 1 or a 0. 0 sounds perfectly fine to me. In order to change the password, the Microsoft documentation states, the netlogon password consists of 512 bytes of random padding minus the length of the password, so it's just, you have the chunk and then the password, with the last 4 bytes indicating the length of the password, totaling 516 bytes. For the simplicity of this room, we can simply supply 516 bytes of all zeros, so null, to make a null password. Eventually, we can work towards creating our own custom password, but once again, for simplicity, we're setting it to a null value for now. So leveling up. Now that we know the required arguments to change the password via nrpc, we actually have to implement it in Python. We need to take a look at the nrpc.py module within Impacket to see the required structure for how we can craft a netar server password to set, or net password set to request. And here we can see that actual module at play. So as expected, most of the field names are the same as what Microsoft provided, except with some differences. Next, we need to know how to structure the authenticator portion as well. And that's what we have right here. The format here is a little bit different compared to the prior, but we'll adjust accordingly when we go to slot it into the POC. But while we're talking about slotting it into the POC, where will our added code go? Our added code will go immediately before the return rpc_con on line 43. This is where we have successful authentication. We want to grab that before we return to the previous function and terminate the RPC connection. Now that we know all the required information that we'll need to add to the POC, we'll save you the painstaking effort of writing your own code, and you can use the pre-written code below. The above explanation should aid in understanding it. And again, I'm going to walk through all this again here in a moment. If this is sounding clear as mud, we'll go through it here in just a little bit. And it makes a little bit more sense when it's actually being demoed. So here we can see the actual additional code that we're going to be slotting into this, and it's all pre-written. So at this point, your code should be good to go, and you should be able to successfully authenticate or successfully exploit 0logon. So all we've done is we've taken the actual POC and we've modified it to grab the additional values that we need in order to go through and reset the machine password to be null, so we can go through and abuse that with additional Impacket modules. And if you're still having issues, you can use the code here, and this is the pre-written code, which makes things a little bit easier. You can just copy this and use it further to just go through the room. So what method will allow us to change passwords over nrpc? That is going to be this method, as I mentioned before. So this is how we're actually going to go through and reset that machine password to null. So what are the required fields for the method per the Microsoft documentation? We can grab all those from right here. The first one is going to be primary name. And then we'll go ahead and grab, it's going to be account name. And then we have secure channel type. And let's see, we need the computer name, computer name, and then we're going to grab the authenticator and the return authenticator. Authenticator, return authenticator, and then we need one more item, which is going to be the clear new password. So clear new password. And this next one's nice and easy. What op number is the method? We can see that here at the top with the op num of 30. And then we have one more thing. We need to modify the POC, which if you were following along with this, you can go ahead and mark this as complete. Otherwise, just grab the pre-assembled POC and we can just use that in the next step. And we're going to go ahead and move on to task 4, which is going to be lab it up. So time to play. Now that you've learned about Zero Logon, it's time to put your newfound skills to the test and exploit this vulnerable domain controller. So you can click deploy here. In my case, I've gone ahead and already started this up. And in this case, I've already gone ahead and taken care of testing this against the machine to make sure everything is working. So after you're done, if you want to play around a little bit more, instead of terminating the machine, you can simply issue the following command to reset the machine back to its original state. So once you have an evil WinRM shell open, you can use the PowerShell.exe with this command, reset computer machine password, to actually fix what you've just done. And if you're confused on how to issue this command, again, you can use evil WinRM, which is installed by default in the attack box. So with this, I do recommend, again, go through with the attack box open, make sure you've installed Impacket as specified in task 2 of this room. Otherwise, you're going to have probably a bad time. So first, we need to go through and scan this the actual domain controller that we're going to be attacking to get these first 3 answers. So the first thing that we need is the NetBIOS name of the domain controller. And if we jump over, we can see that I've already run the scan against this, and we can see that we have the NetBIOS scan here. Let me go ahead, I'll scroll up so you can see what command I ended up using. So nmap-s V-sc. So this is going to be version enumeration. This is going to be common scripts, and then I've saved the output here. So we can go through, and don't worry about this IP not matching yours. This should work just fine. So we can go ahead and grab this, which is going to be our NetBIOS domain name. So DC01, and we're going to hop back over here. DC01, and then we need the NetBIOS domain name of the network. And if we go back, we can see that it looks like we don't have it. Actually, we do here. So it's going to be hololive, and then we have hololive.local for our last one here. And then the domain that we're attacking is hololive.local. And then for these last 3, we actually need to go ahead and run the exploit. And in this case, I've gone ahead and installed it, and I've activated my virtual environment, and we can go up and grab. So I need to adjust this just a little bit to run it against our target machine. So 10, 10, 78, 38. And we can take a look at just how fast this can be. So we'll give it just a moment, and there we go. We can see that almost instantaneously it's gone ahead and exploited Zero Logon, and it's changed the password to be a blank value. I know, blinking, you might miss it. And then we'll go back, and I'm going to go ahead, and just so you can see the command again, that is the command that I used to run the zerologon.py. And we'll run secretsdump.py to pull the secrets off of this target machine. We'll give it just a moment. And here we can see that it successfully pulled these secrets off the machine, so we can either attempt to pass these, which we are going to do here in just a moment with the evil WinRM, or you can attempt to crack them, which realistically in a pen test environment, you do want to attempt to crack these, but if you can pass them, you will. Now let's see. What is the local administrator's NTLM hash? If we go back, we can go back in here. And we'll grab, so the second part here is going to be the administrator's NTLM hash, and we can go over here, and I'm going to grab it off of the clipboard. And we'll put it in there. And then we need to find how many domain admin accounts there are on the machine. If we head back here, we want to be looking for these accounts with the A before their actual names. Sometimes you'll see a different naming structure, but this is typically indicative of a domain admin account. And in this case, we can see that there are 2 likely domain admin accounts on this machine. And then we can go ahead and mark this as 2. And then we're going to go ahead and use evil WinRM with the NTLM hash that we just got to go ahead and get the root flag. And if we go back, let's go ahead. We'll press enter to go all the way down. Maybe. There we go. And we'll run evil WinRM. And we'll do that against 78.38. And I think that should be the same hash. Yes, it is. And we can go ahead and run that. And there we go. Now we have a shell, and you can see how very quickly this exploit went from 0 access to us being the local administrator of this machine. Very scary, very fast. Definitely something that, luckily, Microsoft has already patched this. Make sure that everything is patched, and make sure that you understand specifically what is going on that is being abused in this exploit. If we go ahead and move up to the desktop, we can go ahead and ls, and since this is PowerShell, we'll take my crappy Linux commands. We'll cat root.txt, copy that, and then we can go ahead and submit this and complete the room. We'll grab it here from the clipboard, submit that, and we've gone ahead and completed it. Great job. If this is your first time playing with the POC, welcome to where things start to get a little bit more complicated, but very rewarding. This is definitely a skill that you're going to want to build going forward, and I do recommend playing with this until you understand the process of taking that POC and modifying it to the point where it's actually a usable exploit. As always, if you have any questions, I have the TryHackMe official Discord linked below in the video description. I do have the DarkSec Discord linked as well. If you like this content, subscribe to me on YouTube and follow me on Twitter, and otherwise, I will see you guys next time.